Sorry. There are officially 7 questions on the test. Okay, but let's talk. Tell me how you feel. The first 2 are derivatives. And the last one has 2 parts. That's derivatives. The first one is worth 2 points. Does that indicate its level of...
Yes.
Yes. So it should be pretty quick, right? Taking a derivative. You need to know how to use the product rule. You need to know how to take the derivative of the trig functions. You need to know how to do the derivative of the quotient rule. You need to know how to take the derivative of the ln. You need to know how to take the derivative of the e to a power. Yes.
Do we need to know anything beyond sine, cosine, and tangent as
No.
far as derivatives?
No.
So everything's on the bright colored sheet of paper as far as trigonometric derivatives?
Correct. Okay.
I think
So-
the only thing that I really need to go over with the trig functions is when we integrate and derive cosine and sine. It just keeps messing me up.
But it's on that bright color sheet of paper, which is nice, so you don't have to memorize them. I mean, it's...
Well, it doesn't have the negative, but see, if you're integrating it, you just say the negative goes for the ride, right?
That works, that works.
Okay, so 1 is worth 2 points, number 2 is worth 3 points. Scan down to number 7, because that's another dy dx, find dy dx. For number 2, yeah. The 7th problem, which is the last problem, are just 2 derivative problems. Each are worth 2 points. Okay, so that should indicate to you that they're pretty basic derivatives.
So nothing like we were looking at on the Cambridge tests?
Well, they are part I of a Cambridge test problem.
Okay,
Yeah.
so they're not with
Not building on.
all of the, okay.
That's so
Not
far.
all the solving stuff, just the writing.
Okay, so that's that, okay? Then, that'll be another chapter, actually. So, I mean, it was a good, preview of what's to come. But, okay, and then the third problem is an integral problem. Every single problem I have that you're integrating have an a and a b,
So you don't need to see.
so you don't need a c. I know you like the c.
Less work.
What we're going to do on the poster board today will remind us of the types of integration type problems we have, but could you guys mention some that you know you, yes?
There's integrating by parts, there's du over u, or
Okay.
if you can make it look like that, try to first.
Okay, so that's where we'll start.
Yeah.
Du over u would be the first place I would look if I see a fraction.
If you see a fraction, so the first thing would be, is it a fraction?
Yes,
or no?
is it a
Yeah.
fraction? Yeah. And if it's not, then you should be able to integrate pretty normally, you know. There's other things that could happen, but we really haven't accomplished all of that yet. Yes.
But if it's 2 or more things being multiplied by each other, then that means you have to use integrating by parts.
That really is the best methodology for it. Especially when they have no relation to each other.
Yeah.
Yes.
D over U is the one where you put like ln and then the absolute value of U. Okay.
Okay, so you need to be able to do that. Things to remember about du over u. We did one yesterday where we took the derivative of the bottom, and I think there was a number 1 on top, and we were like, but the derivative of the bottom was 2. So you guys were like, well, just put a 2 there, right? Does that make sense? Yeah. So if your bottom was 2, you took a derivative and you get 2, but your top is 5, you can pull the 5 out. Pretend it's not there. And then,
Put a 2 there.
hello? Yeah. Oh, no time. What's up? We gotta get that turned in. Is it ready to go, or? If it's a number that's not related to the derivative of the bottom, it's just a number, pull that number out. Put the proper number in and divide it by its reciprocal. Does that make sense what I just said?
So if you say pull out a 5 and then put a 2 on the top,
And then pull out
it
a
would just be 5 and a half.
5 halves outside, right. Okay. Then there's you need to know how to take the integral of e to a power. Yeah?
If there's like a number by the X, it doesn't affect it at all, right?
Well, if you're deriving, then you take it and you pull out the derivative of the exponent and put it out front.
But we're talking about integrals, right?
Yeah.
So let's say e to the,
Negative 4x.
there we go, perfect.
Is that what the question's been doing?
Somewhat.
Okay.
So if I'm integrating that, I know that the integral, for me to be able to do the integral of e, the derivative has to be attached to it. So it needs to look like this for me to do it. E to the u du. Has to look like that for me to be able to do the job. So right now I'm looking, I have an e to u. Does that make sense? But I'm missing the du. So what am I going to do?
Pull it out.
Pull a negative 4 right here. Does that make sense?
Put a negative 1/4.
But pull out a negative 1/4.
Yeah.
So if the du is not there, you need to put it there, but you need to accommodate for that. So what would the final answer be? Negative 1/4 e to the u. Done. Yes.
And that's for integrating. For deriving, you just take the derivative of the exponent and bring it to the front.
Well, which makes sense, right? It's
Yeah.
there. So remember, when you take an integral of a derivative, you go back to the original.
Right.
So the derivative would have been e to the u du. Now, the derivative's done, I can integrate. Yes.
So the way of saying that would have been to derive e of u, you just bring the u and put it on the numerator. And then to integrate e of u, you take the u
And put it in the
derivative of u
denominator.
and put it in the denominator.
Okay, so
And how do you derive like that deriving?
How do I derive e to the negative 4x?
Yeah, sure.
So to derive it, you rewrite it. So rewrite it. And then what is the derivative of the exponent?
-4.
Mm-hmm.
There it is.
Oh, so instead of pulling it out, you just leave it.
Right.
Oh, okay.
Integral is when you have to have even,
You have to have it there.
yeah.
Because think about it, the derivative is this, not just that. The derivative is this, so both parts have to be there for you to go back to the integral. Okay? All right, so you need to know how to do that. Now, there are two bonus questions. The bonus questions are similar to what we did yesterday, where it makes you go a little bit further in the process. I would suggest do 1 through 7 first, come back and do the bonus after, okay? I find a lot of times people get stuck on the bonus, and I'm like, seriously? You've got, do the problems first, because those are part of the percentage. The bonus is just added extra. Yes?
So the other remaining 4 are integrate ones?
Yeah, you have an integration by parts, and then one like we did yesterday, where I said, make this look like this
Okay.
with the integration. Did that make sense what I just said? Okay, we did a few of those. Yes.
What if you had the integral of ln of x? Like, how did you do that again?
Can you integrate ln of x?
No.
Then you won't.
So, but then, well, you would use
derive
the, yeah,
So that would be integration by parts and you'd make it your u.
That's,
Right.
That's right. That's right.
because it is derivable, but it's not integratable.
Correct. Correct. All right, so how are we feeling? Right now, we all feel splendid. I'm sure. Yes.
How many points total?
Oh, that's a good question. How many total? Okay. You guys help me out. 2 and 3 is 5, and 3 is 8, and 3 more is 11, and 2 more,
13.
thank you, and 3 more is 16, plus 1,
7.
17. Oh, wait, back up, because part of that was bonus. Never mind. Start over. All right, 2 and 3 is 5, and 3 is 8, and 3 is 11 so far,
That's
right?
me.
And then 3 more is 14,
Yep.
and 5 is
19.
19, and 4.
23.
23 points, and then the bonuses are 1 point and 2 points.
That's
26 total. 23
Well,
now
it'll
bonus.
be out of 23, and then I'll
You
just
can get
add.
26
You can get up to 103 on the test. Does that make sense?
Yeah.
I'm not doing them as, I'm not doing 26 divided by 23, because that would give you like 100 and whatever.
113.
Yeah, we're not going that route.
That sounds really good.
It does.
Like,
Do that.
I don't.
You need it?
Paper towels.
Do I have paper towels? Did you spill?
Can I coffee spilled all over my
Oh, no. I've got, I don't think I have any paper towels. Let's see, I've got these guys.
tissues. And you should have a lot of tissues from last year.
We're pretty much out. We got a lot of snotty-nosed kids in here.
We got one in particular. I turned right around and looked at it.
I got a snotty-nosed kid that I love the most in here. Oh, that's all I got. Okay, are we feeling it?
Yeah.
So then, are all the questions there in part I and part II just one part?
Some of them have one part, and some of them have two parts. Most of them have one part. The second part is a bonus, typically. Okay, so, one of our things that we talked about doing
It's the flow chart.
is the flow chart. So, we want to,
Let me pull out a new sheet of paper so I can write this
I
down.
know,
Wait, what?
so we talked about like, so this is for integration, yeah?
Yeah. I guess you could call it the integration flow chart.
Should I do it in pen?
No, not at first.
Have an erasable pen.
Yeah, do it on the board
board
and then we'll
first.
transfer it.
Finalize it.
That's
We're
smart.
gonna have to brainstorm before we.
That's really smart. Okay, so, because I have an idea and I don't know,
Do you think they'll let us take, let you take this in to the other half to sign the tape?
probably not.
Probably not.
So integration.
I mean, it'll only help me with integration, so I don't know how that's gonna help me much.
But it'll keep you, it'll, like, when we go through this, it'll help. So the first thing is, when you look at an integral, you say, is it a fraction or not, right? So, what would be the first thing we would write here?
Fraction, yes, no.
So, I need a different marker.
I almost brought my markers, but I forgot.
I don't know if that's what it looks like.
Yes.
Would you do fraction, no fraction?
More?
I almost lost my marker.
Oh, we don't want to do that.
That sounds like.
Yeah, I lost my lunch.
I would go home.
If you lost your lunch?
Yep. It's already been one of those things.
Listen, if it's not a fraction, let's go with a no for a minute. Like if it's regular.
Rejoice.
We could rejoice, just take an integral of it.
Yeah.
But the only thing I would worry about is the E situation.
Yeah.
Okay, so keep, like, the things that I would think about is, like, just do it, right? Just try it. Just, right? I mean, just do the integral, right? Is that okay?
What is that little circle thing?
The one?
I thought it was an upside down exclamation mark with the circle around it.
Excited, right?
Yeah.
We got a little excited.
But the things that you need to keep in mind, if it's an integral of e to the u, you must have the du there. Does that make sense? Okay, because that's not a fraction. But for you to be able to take an integral of e to the u, it has to have that du attached.
That was like the one we just did.
That's like the one we just did. Are there any other ones that you can think of?
Wait, I have a question.
Sine and cosine.
Yeah, we just do that.
Yeah, that's
Integration by parts. Now, under integration by parts, I would actually figure out, like I have it in the book, let me pull it out and see if this is something you might be interested in. This book was my go-to book. I love this book. It's my 1999 calculus book that I used when I first started teaching here. Because it's so good. It's so clear. And, you know, math doesn't really change that much, but books do. This always was my favorite. Okay. First derivative, increasing, integration by parts. Substitution in you could look, EJ did artwork in it. I should be so proud.
You should take a picture of
My
it.
child wrote in my book. Isn't that funny? I've had this book a long time. Page 481.
Yeah.
It's one of the reasons why I kept it too, is I thought that was funny. That my kid was writing in my math book and I was okay with it. Okay, so if it's in the format of x to the n, e to the x, or if it's in the format of x to the n, sine of x, or cosine of x, which do you make u and which do you make dv?
Sine.
U is always x here. Does that make sense?
Yes.
Okay, so u will always be your x to the n, and your dv will be the others. Is that helpful for the flow chart?
Well, but can't you do like either one? Because both are derivable and integratable.
Correct, but you want to go,
Easier
Down.
one.
you want to make your easier one, the one that
Yeah,
goes
it's
down
only zero.
to 0, right?
Oh, so we can do the tabular.
Right.
Okay.
The times we can't do tabulars when they both can't be brought down at LN.
When they can't be derivable to 0.
Yep.
And there is an LN.
Okay, so the next scenario is if you have an x to the n, ln of x.
You make
Oh,
LN.
it has to be
U is ln. And dv is the x to the n. Did we do one like e to the x sine of x?
yes. I don't remember.
Yes, the x side of x,
We did?
that exact problem.
Which one did we let u be?
Wait.
E to the x.
Okay. It's either way. All right, are we comfortable? Okay. So is that good so far for the flow chart? That's nice. Anything else? You had mentioned, Billy mentioned, trig
Yeah, trig functions.
functions,
What?
that you must have your du attached as well. So for example, the integral of sine of 2x. What should I do?
It's the chain motion, right?
So what do I need attached to it for me to be able to do this problem?
The derivative of 2.
It's going to be, yeah.
I need the 2. So then I pull out the 1/2.
So it's 1/2 sine of 2, or whatever the integral is.
Yeah, what's the integral of
Cosine.
sine?
Cosine, or no, negative
Negative
cosine.
cosine. So the integral, this answer would be 1/2 negative cosine.
Or negative 1/2 cosine
Yeah,
for 2x.
right. That makes sense?
And the 2 goes away because it's a derivative.
Because you need the derivative of this guy attached to it. No different than you need the derivative.
Of E.
It's like d of x.
Yeah,
Oh, but once you do that, you don't need the 2 anymore.
correct, because the integral takes it away.
Okay.
All right, so is that good? Okay. All right, so fraction, no. We always just kind of blow it off and move on, because we just say, oh, it's a fraction, good. But now you see there's kind of some complexity to it that we must be careful with. What's the next side? Yes.
You can see
Bring it to the top.
the du.
Okay, so I think that's my last resort.
Okay.
Yeah.
So my last resort is if I have to, I'll bring it to the top. So I don't want to if I don't have to.
The U over E.
Yeah, so my first scenario is say, is it du over u? Or some variation of that. So in other words, if it should be a 2, but it's a 5, I can pull the 5 out, make it a 2. Right?
Yeah.
So be careful with that.
And it's the natural log of u plus c.
Right.
And does anything come in front of the ln? Depending on what you have in there.
Depends on what's up
Yeah.
front. What else? Yeah.
Anything cancel?
Can anything cancel? Or can you divide? So if it's larger on top, you could use long division, okay? So larger exponent on top. long division? Would that bring your, would that like kind of bring your memory to what should you do? Yeah, and then you integrate those pieces.
And another thing to remember is that when you're walking or when you're dividing, you have to have every part of every exponent. So if you have to the fourth, you have to have to the fourth, to the third, to the second.
Right,
to the first.
right, you have to remember they're all there. How about, if you have multiple things on top and just one item on the bottom?
Split it
Separate
up.
You could separate them, right? So if you had, can I just show it by example? If you had like x squared plus 2x plus 4, and you were dividing by x, what could you do? You could
Divide
do-
the individual pieces.
Yeah, so you would have, you could rewrite it as x squared over x plus 2x over x plus 4 over x. And then make it easier for yourself to integrate.
And you could divide those, right?
Yeah, right. You would say this would be x, so its integral is x squared over 2. This would be 2, so it'd be 2x.
Mhm.
And this would be 4 over x. What's the integral of 4 over x?
Be the ln of x. 4 ln of
4
x.
ln of x, right.
Yep.
And then for that one, go back and check for number one, right? Just see.
Yeah, you, like this guy. You go back and see if you have that situation for any of the individual pieces. That's exactly right. Are there any others? Any other examples? Yeah?
Bring it to the top as a last resort.
Let me last resort, because you want to try to fix it, that you can get into here. And the only thing when bringing it to the top would be, does it become the du when you bring it to the top?
Mhm.
We did one like that, and I'm gonna probably do it wrong. It has something like this. Am I right?
Mhm.
Yeah.
Oh, yeah.
So, you can't use integration by parts here, because it's in the denominator,
Yeah.
you know? But you can separate it, and what we did was we made it 1 over x.
Pardon me, Miss Kay?
So we rewrote it like that. Now, if this is u,
Oh, yeah.
derivative of it is 1 over x. So now I have du over u,
Yeah.
right? And so what would its integral be? The natural log
Oh, right.
of the natural log
So that's-
of x, right?
Yeah. Yeah. Absolutely.
Nothing.
Plus 6.
So what do you do with that? Do you just leave it like
Leave it
that?
like that.
Okay.
Isn't that pretty? Yes.
So for like the integral of 4 over x,
Uh-huh.
we usually always do it to where we're multiplying on the top. But could we multiply the inside by 1/4 and then?
Well, no, what I would do for this particular one is, no, I know I don't need it, so what I'm gonna do is pull the 4 for the ride and do that.
Oh, okay.
That's okay.
Yeah,
So what would be an example with the longer exponent on top,
Yeah.
long division?
larger exponent on top.
Yeah.
Okay, let me, how do I say this?
Oh.
Try, maybe, or try, like, look for this, or try to create it,
Yeah.
okay? Something like that. It's not factorable, so you can get rid of anything. So you would go,
Well,
x plus 3 goes into,
technically, you factor.
does it?
No.
You could use synthetic division.
Is it factorable? No.
No.
That's,
It was almost.
You could use synthetic
Very
division.
close. It was -3 is the okay.
I tried to come up with one in my head that wasn't.
just a refresh for, that would be x, and then you do x squared plus 3x, and then you subtract downwards.
Yes. So, yeah, if you did the -3.
Yeah.
If you did synthetic.
Let me.
Or, okay, so we'll do it both ways. So I know x goes in here, x times, right? So we have x squared plus 3x. Subtract it all.
1.
That's gone. So I have negative x plus 3, right?
Yep.
So that goes in there -1 time.
Mm-hmm.
So then we have negative x minus 3, right? Just subtract it all. So when I subtract this, that's gone, and I have 6. So plus 6 over x plus 3. So,
What do you do with that?
Now, what you do is you actually have an integral of x minus an integral of 1 plus the integral of 6 over x plus 3.
Okay.
Does that make sense?
Yeah.
So, first one is pretty simple. What's the integral of x? X squared over 2. Right? Minus x. So far, okay. Plus, this is a good example. It is a du over u, but the 6 is like a nuisance.
So pull up 1/6.
Well, no, you go like this. What is the derivative of this? It's 1.
One.
Well, shoot, I don't need a 6. I'm gonna pull this out to the front and just put my 1.
Oh,
And then you put the 6 over 1, but it doesn't.
you just pull up the 6.
Yeah.
I thought you had to reverse it.
Yeah, you can pull it back and forth. So what is the answer gonna be here? 6 ln of the absolute value of x plus 3
Plus
Let's
6.
see.
plus c.
There you go.
When you integrate 1 over x, it's the ln of the natural log, right?
So
It doesn't have to be x. It
Now,
can
an
be
inverse
or-
way you could have done that
It
is
can be anything that.
pulling up to the top and then to x plus 3 to the top, putting it to the power negative 1, and then doing product rule.
No, you're integrating. You're not deriving.
Oh, we're deriving, sorry.
You're integrating, not deriving.
Oh, yeah.
So,
Yeah.
yes for integration. No, I mean, yes. Yes for derivatives, no for integration. Lord,
This
we're
is
gonna
like-
get through it.
This is the only way we know how to integrate that. Okay.
Yes.
if there's like a number over x, then you kind of know to like take it out.
Right, if there's something over x that, or you can have some scenario that looks like this. Okay, what happens here? What's the derivative of the bottom? 2x.
2x.
Well, darn, I have 6x.
12 with 3.
I mean, you could do it, I do it the long way so I can keep in mind what's happening. I need 2x. I don't need 6x. I'm pulling the 6 to the front. I'm putting in a 2, but pulling out.
Okay, okay.
Oh.
That's how
Okay,
I
so
always.
whatever you pull out, and then whatever you replace it with, it goes
Yep.
below it.
Yes.
Equal
All right.
opposite reaction, right?
Yeah.
You have, see, when you're doing that, you're essentially just
Yeah.
dividing by, or making a 1, so you're putting in a 1, so you're not changing the
If you're
actual
smart enough, you know
value.
you need just a 3 there, so you're pulling out the 1/3, that means the 3. You need a 1/3, whatever. I just always
You
show
just
the
pull out
work.
the
You
3.
pull out the 3.
Yeah, yeah. I always make the work
It's
harder.
It becomes 3 ln of x.
Oh, yeah, so it'd be 3 ln of absolute value of x squared plus 3. Do I need my absolute value there?
No.
Because I'm squaring it and adding 3, it's always gonna be positive.
Plus C.
Plus c, I do need the plus c.
Well,
I
yes, we
don't, I don't typically drop the absolute value just because it messes me up if I forget it.
Only A's and B's, let's hope for the grade to be the same.
Yeah.
I need.
What are we thinking?
Yeah.
So we've had, what, 2 tests so far?
Yeah.
I might do those bonuses as the 26 out of 23.
Yeah.
Please. I would say no.
I really don't need
I think that'll be my deal with you all.
Okay. Because we did do this.
Life just got good. Yes.
So it's kind of like when you pulled out the 6 halves, like when we multiply by something and pull out a 1/2, it means that we replaced it, we didn't replace it, so that's why the top is 1 over,
Right.
what did we stick
We
in,
didn't
a 2.
change it, we're using it.
So, okay, yeah.
Yes.
One question. For the A and B, are they gonna be actual numbers? Or like the
I don't know that.
This one.
okay.
Are we gonna be allowed to
Two.
use the flow chart?
No.
If
But-
there are a lot
I would
of
take a picture of it.
if there are a lot of different things like this, like if we have a chapter where there
What did you?
Yeah, I
you
think
have
are options and then a whole bunch of different
You like this?
categories, can
Yes.
you do this?
Yeah, every time? Sure. Every time.
We
I
can
like
do
it.
just about every time in calculus.
You probably could do it with
Stat.
anything we do. I don't know if we're gonna have time to recreate it on here, are we? 10:09.
Yes.
So if you want,
We wrote it down, right? Everybody wrote it
take
down?
a picture of it anyway.
It's on video too.
It's on video. But take a picture of it, that way you have it as well. Honestly, because, and we're gonna build.
It's gonna get longer.
Yeah.
Well, I mean, I'm fine with that because I'm pretty solid on that.
It's making sense now, right? I'm hoping. This is a
I mean, I'm
long
actually-
chapter. I'm trying to figure out what the next thing I want to teach you is. Cause I think,
Can this be that really, that, Brian, that thing that you hinted at yesterday that you said you wouldn't teach us? I really wanna know.
oh no.
What about
But I
the,
think I want to do.
Krajewski rule?
No, I'm not into that yet. I want to. There's two things that are options. One of them is implicit differentiation. I don't think we've done that yet.
That's scary.
Implicit?
I don't think we've done it yet.
Chapter 4.
Love it, love it, love it, love it, love it. It's one of my favorite things to teach, and it's all over the tests.
Okay.
It seems
Or
pretty-
integration, partial fraction decomposition integration.
I'm sorry, that
Yeah.
I think we
They
should,
both sound horrific, but they're actually,
is when you die inside.
yeah, a little, not much, a little. No, seriously, either of those two will be like, oh, I got this.
You know, it's scary to think that next year I have to take a higher level math than this.
A lot of kids last year decided to redo Calc 1. I don't know why. They went back in just a direction.
Well, that's the last resort move to the top,
I
right?
think that's it.
Once you move it to the top, you just do it like that, right?
What's that?
Once you move it to the top, you just do it like that, not fractions.
so,
Yeah.
my friend from Merritt Island messaged me again last night about derivative, and she's like, I don't know what to do with E, and I'm like, it took me a year to get from derivatives to E derivatives and everything, and she was like, I still don't understand, and I'm like, I can help you, and she's like,